G'day everyone, so we're running through the Chapter 1 Test B this time, and what we're going to do is just work through the solutions, see how we go. You'll be able to check your working, find out where you went wrong and fix up your mistakes. Whichever test you did first, whether it was A or B, grab a copy of the second one. You can ask me or I'll put them here in the OneNote file and then have a go at the other one and then check your answers again. That way you've got a chance to practice and learn from your mistakes, which is what it's all about. First up, expanding and simplifying. So expanding 3x by x, 3x squared, 3x by negative 2, negative 6x, negative 2 by x, negative 2x, negative 2 by 3, negative 6. That's 3x squared minus 8x minus 6. The answer's A. The next one, simple evaluate. Make sure when you're substituting in values that you use brackets. That'll make sure when you go negative 4 squared you get positive 16, not negative 16. So negative 4 all squared plus 2 times b is 5, times c is negative 3. That corresponds to 16, take away 30, negative 14. Next one, got to find a common denominator here. Quite obviously, when we've got algebraic terms, almost always the common denominator is just the product of those terms. So there we go. The first one needed to be multiplied by x plus 7 over x plus 7. Remember, the reason I do it over that is to get the denominators the same, and multiplying by 1 will not change the value. This second fraction needed to be multiplied by x take 4 over x take 4. So I have 3 outside of x plus 7 plus 5 outside of x take 4. Simplify that, I'm going to have 3x from the first bracket and 5x is going to give me 8x altogether. 3 sevens are 21, 5 by negative 4 is negative 20, 21 minus 20 plus 1 over that denominator, but you can already see that the answer must be D. Let's just finish it off though, because it looks nicer if we actually finish our working, doesn't it? Alright, there we go, on to the next one. Inequality. Shaded in circle includes a point, open circle does not include the point. So these are x values that are less than or equal to 7, greater than 5, corresponds to E. Pretty straightforward, that one. Which of the following points does not lie on the line? All you do is you sub in the x value and see what you should get. So when I sub in 4, y is going to be negative 2 times 4 plus 7. Y equals negative 1. No, it looks like that point is on the line. Let's try the next one. When x is 1, negative 2 plus 7 is 5. So that point B does not lie on the line, and you just check it again. 1, so negative 2 times 1 is negative 2 plus 7, not 5, not 3. We are done, we don't even need to check the other answers. Question 6, horizontal lines. Horizontal lines always have the same what? They have the same y coordinate. This is going through negative 5, 9, which might be that point there. Horizontal line through those points must have a y coordinate of 9. So that becomes the equation, doesn't it? Y equals 9. Trying to find the rule of an equation. What are the two things we need? The y-intercept, which in this case is 0. We can see that right there. And the gradient. Well, here, just find 2 points that we can see the coordinates for. So we've got the origin and this point, 2, negative 3. So to get there, we've gone down 1, down 2, down 3, and across 2, remembering that a gradient is rise over run, which in this case is down 3 and across 2. Since y equals mx plus c for any straight line, except for those tricky vertical ones, we just fill in the blanks. Y equals negative 3 over 2x, and c was 0, so negative 3 over 2x. There we have it. The gradient of the line joining the points. How do I find a gradient? If you're not sure, at the very least, what you could do is sketch this really quickly. Negative 2, 1. That's going to be about there. 6, negative 3. There's the point 6, negative 3. This is the point negative 2, 1. And you can count it off that. Down 4, across 8, negative 4 over 8. Oh, bumped my button there. Negative 4 over 8, which is, of course, negative 1/2. If you wanted to do it using the rule, you would just start with y2 take y1 over x2 take x1. The rise is the difference between y coordinates, and the run the difference between the x coordinates. So when I substitute those values in, I'll have -3 take 1 over 6 take -2, which of course leads me to that answer there. So you can see you can do it by drawing a quick sketch or by using the rule. If you get stuck in the exam and you can't remember exactly what the rule is, do the diagram and count the steps. Easy, piece of cake. Alright, the equation of the line shown is, where's my pen gone? There it is, found my cursor, excellent. -3, so the y-intercept is -3. What's my gradient? Let's check my rise over run. Up 1, up 2, and across 1. So my gradient is 2 over 1, which is of course just 2. So y equals 2x take 3, corresponding to letter E. Midpoint of the line segment. How do I find a midpoint? It's just the average of the x-coordinates divided by the average of the y-coordinates. x1 plus x2 over 2, y1 plus y2 over 2. Remember, the middle is just the mean or the average value, so it makes sense to do it this way. Here I've got -3 plus 5 divided by 2 and 1 plus 3 divided by 2, which of course gives me the coordinates. 5 minus 3 is 2, 2 divided by 2 is 1, and 4 divided by 2 is 2. So the coordinates are 1, 2, and that corresponds to letter D. On to part B, short answer. What do I do here? Identify your like terms. Find where my pen is. There it is. AB squared. There's another AB squared. So I have 5 AB squareds. This one here is at A squared B, as is that one. So -7 plus 3 is -4A squared B. Multiplying. Number by number, letter by letter. 2 5s are 10. 1c multiplying by another c becomes c squared. 2 d's multiplied by a third d becomes d cubed. Pretty straightforward. When I cancel fractions, what can I do? Cancel common factors. There's an f there and an f there, so they become 1 each. Excellent. 8 and 2. Well, 2 goes into that once and into 8 4 times. Finally, I've got e squared and e, so one of the e's on the bottom cancels with one of those, and I'm left with a -4e in the numerator, 1 in the denominator, so that's my answer, -4e. Careful, we just mentioned we can only cancel common factors, so for this one here, although it's tempting to cancel straight away, make sure you factorise first. 2k take 3, you can see the common factor was 3, so I put 3 out the front. 6k divided by 3 must be 2k, and 9 divided by 3 is 3. Now I've got a factorised expression in the numerator. I can eliminate that denominator, and my answer is just 2k take 3. Again, can only cancel common factors, so for this one over here, 6 goes into 6 once, and into 18 3 times. This expression isn't factorised, and in fact can't be, so I'm left with m plus 3 over 3m. That's all I can do. Next one, what is division? It's the same as multiplication by a reciprocal. So when I'm dividing by a fraction, I multiply by the fraction turned upside down. Now, I can only cancel common factors. That numerator there looks like it could be factorised. 5n is a common factor, and I'd have another n and a plus 2 left over. And here I have a 2n. Cancel common factors now. n plus 2 cancels with n plus 2. N cancels with n. Remembering when these things cancel, they're really going to ones. 2 is an even number. There's a 6 up the top that's even, so 2 goes into 2 once and into 6 3 times. So I've got 5 times 1 times 1 times 3. 3 5s are 15. Problem solved. All right, next one here. Can only add or subtract if they have common denominators. So this one gets multiplied by x over x. The first one gets multiplied by 7 over 7. Doing the maths, I've got a fraction with a denominator of 7x. 7 3s are 21. Plus 4 times x is 4x, so it's 21 plus 4x over 7x. Finally, got to write them with the common denominator. It's not solving an equation, so I can't just multiply through by 20. I need to write them as 20ths. The first expression got multiplied by 4 over 4, so that's 4 times 2x take 3. The second one was multiplied by 5 over 5, so it's 5 times x plus 1. Simplifying that, I'm going to have 8x plus another 5x is 13x. Negative 12 plus 5 is negative 7 over 20. There we go. Getting closer to the end now. Solve the following equations. What do I do first? I want to make sure that I am undressing the x. So what do? We get rid of whatever's got the least to do with it first. Add the 3. So that's equivalent to 4x. 17 plus 3 is 20. That 4 looks pretty dodgy. Well, that sort of makes it look a little bit better. Sorry about that. Opposite of multiplying by 4, dividing by 4. So then I'm left with x equals 20 divided by 4 is 5. Last one here, x plus 8 over 5 equals 3. I don't like that divided by 5, so I'm going to multiply by that first. So I'll have x plus 8 equals 15, then I subtract 8. And x is 15 minus 8 is 7. Alright, let's keep going. 2 outside of 3x plus 5 equals 4x. You could cancel a 2 or expand first. I think I'm just going to expand first in this one. It doesn't really make much difference. Let's do it that way. So 6x plus 10 equals 4x. If I subtract the 4x from each side, even though I could subtract the 6x and save myself a line of work, we are better off working with positives. So let's do that. So 6x minus 4x, I'm going to have 2x plus 10 equals 0. So subtracting 10 gives me 2x equals negative 10, dividing by 2, x equals negative 5. Next one here, great. One where we've got a fraction equaling a fraction, multiply through by the common denominator of 6, and we're going to have 3 multiplying this numerator, so that's 12x take 9, equals 2 multiplying this numerator, 2 by 3x is 6x, 2 by negative 4 is negative 8. Subtracting 6x from each side, I get 6x. Adding 9 to each side, 6x equals 1, therefore x equals 1/6. There you have it. Getting closer. Inequalities, what's the only thing we need to remember? If you multiply or divide by a negative, change the sign around. Other than that, you're all fine. So this one here, I've got a choice. I could subtract the 5, or I could multiply by 2 to get rid of this denominator first. I think for this one, I'm going to multiply by 2 first. In the other test, I've done it the other way. This one, I'm just going to multiply everything by 2. So I'm going to have 10. When I multiply the second bit by 2, the denominator is going to cancel with the numerator that I'm multiplying by. So it's just going to be 10 minus x, and over here, less than 2 eighths are 16. Subtracting 10 from each side, I'm going to get negative x is less than 6. Remembering now to get x on its own, I've got to multiply or divide by negative 1, whichever way you want to think of it. So x, I've got to change the sign around because I'm multiplying by a negative. X is greater than negative 6. There you have it. Right, our next one here is not so bad. Subtracting 4x from each side, we'll get all my x's together. If I'm getting them on the right, I want to add 6 to get rid of that 6. 4x minus 4x disappears. 9 and 6 is 15, is greater than or equal to 3x, dividing by 3. 5 is greater than or equal to x. Usually with an inequality, we like to write it with the x first. So what's that equivalent to? That's x is less than or equal to 5. And there we have it. Graph the following linear equations using the given method. Gradient and intercept. Y-intercept, the y-intercept is the number at the end. That's 2. That's easy enough. Oh, the grid hasn't shown up very well on this. That's okay though, and it just wobbled around when I did my little circle. There you go, there it is. Stop being naughty. Oh, right, that's good. Gradient, negative 4 over 3. So I go down 4. 1, 2, 3, 4. To the right, 1, 2, 3. So the other point I'm using is the point 3, negative 2. This is the point 0, 2. And I join those with a nice straight line. Now, as you will see, I can't see what I'm doing. I cannot see it all. Let's try and do it in a little bit prettier fashion. I'm going to go through there like that, but I've chosen the wrong sort of arrow. 27th time's a charm, that's what they say. Let's get the double-headed arrow. Try again, going through that point and that point, and I might need to just neaten it up a little bit. It's just a bit tricky because on this one I can't actually see it where I'm writing. I have to look at the screen and write down, so that's why it sometimes gets a little bit grubby than when I'm writing at school. But either way, label the equation, y equals negative 4 over 3x plus 2. You're done. Next one, using the axis intercept. So to find the x-intercept, what do? I let y equal 0. That would give me 2x equals 6. The x-intercept, 6 divided by 2, is 3. Got 1 point. For the y-intercept, I let x equals 0. What does that mean I have? I have negative 3y equals 6 divided by negative 3, y equals negative 2. Put your dot in there, join them up. For some reason, it's a lot easier going in that direction. I don't know why. But there we have it. Label the equation. 2x take 3y equals 6. Problem solved. Getting close to the end now. You're doing well, guys. If you've stuck around for all of this, find the equation of the straight line shown. Straight lines have equations y equals mx plus c. C is the y-intercept, which in this case is, it looks like negative 5, but I probably can't be certain because it's not actually labelled. Maybe it's negative 0.48. I can say for certain what the gradient is. I'm going from the point negative 4,1 to 2,8. So how far down have I gone? 2, negative 8. 2, 3, 4, 5, 6, 7, 8, 9. The difference between 1 and negative 8 is 9. That makes sense. So the gradient is the rise, which in this case is actually negative 9, divided by the run. How far across did I go? I went from negative 4 all the way to 2. So that's 1, 2, 3, 4, 5, 6. Negative 9 over 6, which you can simplify to negative 3 over 2, dividing top and bottom by 3. So now I know y equals negative 3 over 2x plus c. Let's sub in a point to calculate c and see if we were right in our suspicion that it might be negative 5. I'm going to sub in the point to negative 8 because I can see that 2 is going to cancel nicely there. So what does that give me? It gives me negative 8 equals negative 3 over 2 multiplied by 2 plus c. 2's cancel. Opposite of subtracting 3 is to add 3. So negative 8 plus 3 is negative 5 equals c. Ah, look, we did get it right. Finally finished by writing your equation. Therefore, y equals negative 3 over 2x take 5 is the equation of the line. If you really want to write that, you can. Getting close. Distance formula. Where does distance come from? It comes from Pythagoras' theorem. If you can't remember in the exam, just remember that Mr. Chua said it came from Pythagoras' theorem. Go ahead, draw a sketch, figure it out, and you'll be on your way. So negative 1, 5, so there'd be negative 1 about there, 5 there, rough estimate. There's negative 1, 5, and the point 4, 2. 4, 2. Find the exact distance there. Of course, we make a right angle triangle and it becomes pretty easy, doesn't it? This distance here, that's got a y-coordinate of 5, and the other one's got a y-coordinate of 2, so that distance is 3. For the horizontal distance, I start at negative 1 and I end up at 4, so that's 5. And then you can go ahead and just use Pythagoras' theorem. The distance equals distance squared equals 3 squared plus 5 squared. So the distance is the square root of whatever that adds up to. 9 and 25 is 34. If you want to use the rule rather than having to write that out, what is my actual rule? Distance equals the square root of y2 take y1 squared plus x2 take x1 squared, which in this case is 2, getting carried away, 2 take 5 squared plus 4 take negative 1 squared, which then you'll see it's the square root of 3 squared is 9 and 5 squared is 25, which gives me a distance of root 34 that we had before. Not so bad. This one's slightly more challenging. Find the values of a if the distance between a1 and 6, negative 2 is 13. So, is root 13, sorry. So root 13, and this is where I have to use that equation, equals the square root of y2 take y1, negative 2 take 1 squared plus x2 take x1. 6 minus a all squared. Both sides are being square rooted, so I can square them. That's not too bad. So 13 equals negative 3 all squared becomes 9 plus 6 minus a all squared. Subtracting 9 from each side, I get 4 equals 6 take a all squared. You could square root and use your plus or minus. I will encourage you to instead use your favourite rule in maths, the difference of two squares. So I've got 6 minus a squared minus 4 equals 0. I actually subtracted 4 and moved it to the right, but it's nicer if I put it on the left, so I've done it that way. Difference of two squares. How do I do difference of two squares? For this, I'm going to have 6 minus a plus 2, because 4 is 2 squared, and 6 minus a minus 2 equals 0. What does this one give me? A equals 8. This one here gives me a equals 4. And they're the two values of a that'll make the distance root 13. So close to the end. Parallel, perpendicular, or neither. This first equation has a gradient of 2. What about this second one? Got to get it in the form y equals, don't we? So I'm going to subtract x first. So I've got 2y equals negative x plus 8. Dividing by 2, y equals negative x over 2, or negative a half x, plus 4. What do I know about gradients? They're not the same, so they can't be parallel. If m1 multiplied by m2 equals negative 1, they are perpendicular. Let's check it. 2 by negative 1 half. 2's are going to cancel negative 1. Therefore, they are perpendicular lines. Somehow left off the other bit there. There you go. We are almost there. What do we got? 3 more pages. Almost done. Find the equation of the line parallel to negative 3, 5, and passing through the point negative 3, 2. So we know the gradient is negative 3. What about the y-intercept? Don't know yet. Y equals negative 3x plus c is all I know. So I sub in the only point that I know is definitely on the line, and that's negative 3, 2. So I would have 2 equals negative 3 multiplied by negative 3 plus c. 2 equals 9 plus c, subtracting 9, negative 7 equals c. Therefore, y equals negative 3x, take 7. Simultaneous equations using the method of substitution. So what I'm going to do is take this expression, y equals 3x minus 4, substitute it into the other one. So I say sub 3x minus 4 for the letter y in, and I should have labelled these equations, that's equation 1, and I'm using the substitution from equation 2. Therefore, equation 1 has become 5x take 2, 3x take 4, equals 4. 5x minus 6x, negative 2 by negative 4 is plus 8, equals 4. Negative x is the sum total of my x's. If I subtract 8 from each side, I've got negative x equals negative 4, x equals 4. I am not done yet. I must find y. So I say sub x equals 4 into, and I choose an original equation, and this one obviously equation 2 is easier because it's already got y equals. It's already done the hard work for me. So therefore, y is going to equal 3 times 4 minus 4. 12 minus 4 is 8. Does 4, 8 work for the other one as well? 5 4s are 20, minus 2 8s are 16, 20 minus 16, 4. You know you got it right. Check both of them. Good stuff. Marcus and his friend Dean are selling tickets for the fun run. Between them they sell 120 tickets. So we define our variables first. Let m equal number tickets Marcus sells, and D equal the number of tickets. Whoops, got it backwards there. Number of tickets. That's a TK. Oh, now I've lost my pen. There it is. TS. Dean sells. You'd write it out nicely in an exam. I'm a bit cramped for space there. You'll have plenty of room. Between them, they sell 120 tickets. So M plus D equals 120. Also, Marcus sold more than Dean by 16, so M equals D plus 16. Find out how many each sold. This is set up for substitution, isn't it? We've got our equation 1 on the left, equation 2 on the right, and I say sub 2 into equation 1. That's fine. What does that give me? It gives me D plus 16 plus D equals 120. 2D equals 104. Therefore, the number of tickets Dean sold equaled 52. What does that imply? It implies Matt's tickets sold, no, Marcus's tickets sold. 52 plus 16, 68. Add them together, it's 120. So we're pretty sure we got that right. Next one, only trick is setting up the equations. To compete in the fun run, tickets are $5 for adults and $3 for children. So we're going to have to just change our variables. Let little a equal number of adults tickets sold. And what about little c for the number of child tickets sold? Write a pair of equations. Well, one thing I know is that we sold 120 tickets, so therefore a plus c equals 120. I also know prices. So 5a plus 3c is going to equal the total amount of money, which is 458. All right, there's my equation 1, equation 2. They want me to use elimination when you get further down in part C, so let's go ahead and solve that. I'm going to do equation 2, and I'm actually going to get the number of c's to be the same. Let's go with c's. So if I multiply equation 1 by 3, what does that give me? It gives me 3a plus 3c equals 360. So, doing subtraction, where am I writing? There it is. Equation 2 minus equation 1 times 3, and I could just write it like that if I like. What does that give me? 5a minus 3a is 2a. 3c minus 3c disappear as expected. 458 minus 360 is going to be 98. Therefore, A is equal to 49. What does that mean? We sold 120 altogether, so I sub A equals 49. Sub A equals 49 into one of the equations. I'm going to choose equation 1. Therefore, 49 plus C equals 120. Subtracting 49, C equals 71. You can always check it in the other one. 549's 245, 371's 213. So whatever we said for that one, 245 plus 213 is 445 plus 13, 55, 56, 57, 58. Made it, got it, done. One to go. Awesome stuff. Let's finish it off. X is greater than or equal to 0. X equals 0 is a vertical line. Again, bear with me here while I'm trying to write, not on the screen, but on a little bit of plastic. So you get the right idea. That should be on the axis. X greater than 0. Well, X is greater than 0 to the right of all of those points, isn't it? So I know it's on that side somewhere. I think I have to do backwards when I'm looking at my mirror, looking at the photo there, but that's all right. Whatever. Y is less than negative x plus 9. Well, that's got a y-intercept of 9 and a gradient of negative 1. So I'm going down 1 and across 1, aren't I? Whoa. Control Z. There we go. It's back. Down 1 and across 1. That's being difficult. But the good news is, because this was a less than 1, I need to do a dash line so I can sort of control it. I'm having trouble getting the right angle, aren't I? But you get the idea. Down 1 and across 1. There we go. Where's my pen gone? There it is. And that's the equation. Well, I should keep going right through the axis there. Almost done here. So there we go. And I want the y values less than that. If I sub in the origin, 0 is less than 9. Yes, so I need the side that the origin is on. So I'm going to have the underside of that one. I've got to the right of the first one. Last one there. Y minus 2x is greater than or equal to 3. Let's just rearrange that. Y is greater than or equal to 2x plus 3, so I'm going through 3, a gradient of 2, up 2 and across 1, up 2 and across 1, just to make sure I get the right points. I'm going to actually go for one of their lines this time, why not? See if that helps me a little bit. Oh, it did, except it clicked off very quickly, but there we go. We can get it going pretty much through those points. You, of course, will be able to get it perfectly. What's the last thing I need to do? Shade the required area. Should be right up to the axis, so I'll just do it there. Now, of course, you can just do lines, or you can shade it if you've got a coloured pencil or something in the exam. Last thing we do is just mark that I've actually shaded the required region. Alright, takes a bit longer talking through it than actually just doing it, but you can see there, half an hour all done. Probably you could do that in 20 minutes or 15 minutes if you really knew your stuff. But look, if we were giving you that in an exam, you'd have 80 minutes to do it, so you'd have heaps of time. But don't be afraid to try and work quickly either. I hope that helps. Well done if you stuck around for the whole video. Hopefully you just put it in fast forward and watched it that way, or just jump to the bits you need. Keep up the good work. See you in the next one. Good night. Time for me to go to bed. Cheers, guys.